There is another way we can describe the transfer function approach. In mathematics, when we study linear differential equations, we come across an equation which is total response is equal to 0 input response plus 0 state response. 0 input response will be the response when the input will be considered to be 0. Therefore, 0 input response will be totally dependent upon the initial state of the system. Similarly, when we talk about 0 state response, it means the initial state of the system are assumed to be 0 and the response will be corresponding to the input provided to the system. Now if we assume the 0 input response is equal to 0, which means that the response corresponding to the initial state of the system is 0, then the total response will be equal to 0 state response. If such condition arises when the 0 input response is 0, then we can apply the transfer function approach. But if you come across a question in exam where the initial state of the system is not 0, then you have to go through space state variable approach. Now try to understand this point through a question. In this question, you are supposed to find the ratio of the Laplace transform of the output to the Laplace transform of the input, and the initial current and initial voltage across the inductor and capacitor is also provided. You know, inductor and capacitor are energy storing devices, so these components can have non-zero initial state conditions. And since in the provided question they have initial values, therefore the final answer or the ratio will not be the transfer function of the system. In such questions, when the initial conditions are not zero and you still try to find the answer through transfer function approach, then it will be very lengthy. By using transfer function approach, you can find the zero state response, but you still need to find the zero input response. And for finding that, you have to first derive the differential equation which represents the system's dynamic behavior, and you have to solve them separately to find the zero input response. But this type of approach is never appreciated as it will make your solution very lengthy. So I hope you can clearly determine in which questions you are supposed to approach through transfer function and in which questions you should be applying a state variable approach. Now focus on another point. In electrical circuits, you will study two equations. Voltage across the inductor is equal to inductance multiplied by the differential of current flowing across it. Similarly, the current through the capacitor is equal to capacitance multiplied by the differential of voltage across it. These two are the very basic equations which represents the behavior of inductor and capacitor, and the tool Laplace transform has extensive uses. This tool is used in network theory also. By converting these equations from time domain to frequency domain, we will get voltage across inductor equal to inductance multiplied by Laplace variable S multiplied by the Laplace transform of current minus the initial current flowing through the inductor. Similarly, we are also having the equation of capacitor. In the right hand side of both these equations, we have two terms. The left term are representing the impedance of inductor and capacitor, whereas the terms on the right side are initial state parameters. This is the exact equation which you will be using a lot in network theory or electrical circuits, but in control systems, since most of the topics are dependent on transfer function, so mostly we'll be using the impedance parameters only. In control systems, particularly when we are supposed to use transfer function approach, then when we have to convert a network from time domain to frequency domain, resistance will remain resistance, whereas inductor will change to Laplace variable S multiplied by the inductance, and capacitance will change to 1 divided by Laplace variable S multiplied by the capacitance. Remember, this will be used only in control systems, and that also only when the initial conditions are 0. You should not be using these equations in electrical circuits or whenever in the question there are initial conditions for inductor and capacitor.